दिस इज द रेट ऑफ चेंज ऑफ मोमेंटम। मोमेंटम क्या होता है? मोमेंटम होता है मास इंटू वेलोसिटी। मास इंटू वेलोसिटी। सो द मोमेंटम, इसका मतलब क्या होता है? मोमेंटम मोमेंटम होता है मास m इंटू वी, मास इंटू वेलोसिटी। वेलोसिटी कितनी है, उन दोनों को मल्टीप्लाई करेंगे तो वो आ जाएगा मोमेंटम। रेट ऑफ चेंज ऑफ मोमेंटम इज डायरेक्टली प्रोपोर्शनल टू द applied force and this change always takes place in the direction of the applied force। जिस डायरेक्शन में, सपोज करो एक बॉक्स है ये, अब हमें इसको इस डायरेक्शन में अगर फोर्स लगाते हैं, इसको F कर देते हैं हम लोग, और ये अगर जिस डायरेक्शन में फोर्स लगा रहे हैं ना, उसी डायरेक्शन में आपका अप्लाइड फोर्स एंड द चेंज ऑफ ऑलवेज टेक्स प्लेस to the direction of the applied force। जो चेंज आ रही है ना, चेंज इन मोमेंटम विल बी इन दिस डायरेक्शन। चेंज इन मोमेंटम, चेंज इन मोमेंटम, चेंज इन, जो चेंज है ना, बदलाव आ रहा है, जो दैट इज अ चेंज इन द मोमेंटम, चेंज in momentum। मोमेंटम क्या होता है? फोर्स इंटू वेलोसिटी, मास इंटू वेलोसिटी। मोमेंटम, सो द चेंज इन मोमेंटम डायरेक्शन विल बी दिस सेम, यही वाली डायरेक्शन रहेगी जो डायरेक्शन फोर्स की है। दिस इज द सेम डायरेक्शन and so dp डिवाइड बाई dt। dp क्या हो गया? ये वाला जो है ना मोमेंटम हो गया p विद रिस्पेक्ट टू द टाइम। रेट ऑफ चेंज क्या हो जाएगा? रेट ऑफ चेंज का मतलब ये है जैसे मोमेंटम डिफरेंशिएशन ऑफ द dp बाई dt, dp बाई dt इज़ प्रोपोर्शनल टू द फोर्स वेक्टर। मतलब ये जो रेट ऑफ चेंज ऑफ मोमेंटम को कैसे लिख सकते हैं हम? ये रेट ऑफ चेंज ऑफ मोमेंटम जो है उसको हमने लिखा है, दिस इज रिटन एज डी पी वेक्टर बाई डी टी। डी पी वेक्टर क्यों लिखा है? क्योंकि वेक्टर इज अ, दिस इज द वेक्टर क्वांटिटी, मोमेंटम इज अ वेक्टर क्वांटिटी, मोमेंटम इज अ वेक्टर क्वांटिटी एंड टाइम इज अ स्केलर क्वांटिटी। मोमेंटम क्या है? मोमेंटम इज वेक्टर क्वांटिटीज, इट हैज़ डायरेक्शन, बिकॉज इसमें वेलोसिटी आती है मास इनटू वेलोसिटी। सो दिस इज़ अ वेक्टर क्वांटिटी एंड टाइम इज़ अ स्केलर क्वांटिटी। टाइम इज़ स्केलर, टाइम इज़ स्केलर क्वांटिटी। स्केलर क्वांटिटी मीन्स इट हैज़ नो डायरेक्शन, so this is scalar quantity, whereas momentum is vector quantity. This momentum is vector quantity and it has direction, and the direction, its direction is the direction of the force in which we apply. This is a vector quantity, this is a vector quantity. Momentum is a vector quantity and time is a scalar quantity. So next is F vector is equal to dp vector by dt. F vector is equal to, F क्या है? Force. Force is a vector quantity. This is a force, applied force है ये, this is applied force which is a vector quantity, applied force, force applied by a body. This is applied force, so this is a vector quantity, vector quantity. So that is, we are applying it, it has direction it has direction. So this is, it has direction, so we have just placed vector over it. It has direction and we have placed a vector over it. Direction. And this is momentum. Momentum has again got, it is a vector quantity, so we have P means momentum. This is a momentum, so we have denoted it by a vector. This is a vector, it has some direction, and whereas time is having no direction, time has no direction, so there is no vector over it, like it is vacant, there is no vector over it, because that it is a scalar quantity. And we add in it d p vector is equal to mv vector. So d by dt of mv, this is equal to m of dv by dt plus v vector dm by dt. M is a constant. P vector is a momentum, मतलब P vector, this is given here, ये दिया हुआ है. So we have just placed the value of the P vector into this equation. So this is mass into velocity, mv vector. So whereas this is a constant, m is a constant, so whereas m is a constant, so m dv by dt v vector, d by dt of this will be dv, m is a constant, see bahar aa jayega, this will be left here, and plus v vector, this is a constant, m is a constant, m is a constant, this is a constant, so we can write it like this, and then add in it v vector dm by dt, dm, m is a constant, so v vector we have placed it here. F vector is equal to m dv vector by dt. M is a constant, dm by dt is equal to 0. Okay, this is 0 because differentiation of any constant is 0. So this is m dv vector, m, this is 0. Its value is 0 because the constant, differentiation of the constant is 0. Differentiation of the constant is 0 according to the maths. Differentiation of a constant is 0. Differentiation, right? Differentiation of a constant is 0. Differentiation of, this is a constant m, here d by dt of dm by dt is equal to 0. This is differentiation of differentiation of a constant, differentiation of a constant is 0. डिफरेंशिएशन करने वाला, चलो ठीक है. Above the result is not Newton's second law, rather it is conditional result obtained from it under the condition where m is constant. Numerical application is acceleration is equal to net force divided by mass. F is a resultant of the vectors. This is the resultant of the vectors. If n vector is the resultant of all the forces acting on the body. So this is first force, this is second force, first force, this is the first force, and this is the second force, this is the second force, this is the third, fourth force. So the net will be F1 plus F2 plus F3 plus F4 plus F5 plus S6. So this is the resultant of all the forces acting on the mass of body M will be equal to F1 vector plus F2 vector plus F3 vector, because all the forces are outside, going outside, moving outside. So this is the net force is equal to, this net force is equal to sum of all the forces here acting on the body. So we have written it in that direction. Next is physical application, horizontal. A body kept on the horizontal plane is at rest. So this is mg, mass into acceleration, and since the body is at rest, so g is the gravitational force, acceleration due to the gravity, mass into F is equal to ma. F is equal to ma, mass into acceleration, a, where here the a has been converted into g. So F is equal to mg. Mg means mass into gravity, acceleration due to gravity. So mass into gravity, mg. So this has been converted. The mass into acceleration becomes acceleration due to gravity. This is changed here because because it is moving downwards. So we have to take the force as acceleration due to the gravity. So next is horizontal force. Now they have taken F is equal to ma. Why they have taken the ma? Because this is the real formula, but here because it was downwards, so they have taken mg. Instead of a, it was g, but now in the horizontal direction, in this direction, if we take horizontal direction, we will take mass into acceleration, mass into a, acceleration. If a body is kept on the horizontal plane, is accelerating horizontally towards right under two horizontal forces. So this is the positive axis, this is the x-axis, suppose, and now this is F1. F1 is positive because according to the this is y-axis, quadrant formulas. This is positive, this is the positive direction here, this is the positive direction of the x-axis. This is the positive direction of the x-axis, positive direction of the x-axis, and here it is the negative direction of the x-axis. So we have taken this as, this is positive, so this will be F1, here it is written F1, and because it is negative, so this will be negative, because it is the direction is of the forces in the opposite, in the direction of the negative part of the x-axis. This is the x-axis is negative in that direction, so it is taken as F1 minus F2, because F1 here it is plus, because it is a positive direction. Here it is this F2 will be negative because it is in the negative direction of the x-axis, because we know about the x-axis and y-axis. The body kept on the horizontal plane, accelerating horizontally under a single inclined force. So this has been explained here. This is a theta. So if we go for fx, if suppose it is f of x, suppose we take it as x, in this we take it as f of y, f of y. If we take it like that, then we place a perpendicular line here, should be coinciding with the arrow, but it is not. So we have to just draw a line exactly perpendicular towards it. So this is perpendicular. So this is f. So what is the cos theta value? Cos theta here will be cos theta is equal to b by h. So what is b here? B is fx. This is the b, base. So fx by this is the force F, this is H. H means hypotenuse. Mark it by H. So F divided by F. So if we take it this F is to be taken. If we take this F towards the right side, then f of x is equal to f of x is equal to f cos theta. F cos theta. So we've got the value of the fx axis. Now we go for the y axis. So what will be the value of the, here will be sine theta, we'll take up sine theta. Sine theta is equal to how much? It will p by h. Sine theta is equal to p by h. P by h, p is this much. Because if we go for this value, this is f of y. This is f of y. Y means on the y-axis we've taken. So sine theta, what will be sine theta? Fy by f. Fy by f. So if we take this f towards the left side, then f of y is equal to f of sine theta. F of sine theta. So we have got f of y is equal to f of sine theta. So we have got this value. These are the two values, like this is the value coming, f of sine theta, f of cos theta. How they came, that was I was explaining it to you. Because this is the way this values came. So next is for the vertical direction, n plus, because all the directions have to be taken. This is f of y. Is this f of y? That is f of sine theta, and it's the same direction, n is there. So this is equal to mg, because this is in the opposite direction. So this is right, because n is n plus f of f sine theta is equal to mg. And here in the horizontal direction, that will be in the horizontal direction, that will be here is f of cos theta is equal to ma, because acceleration is in this direction. So in this direction it will be ma, because a is in this direction, So its opposite direction will be force, MA. So this is there, f of cos theta is equal to MA. This is over. For the vertical body kept on is accelerating towards the right under an inclined force. So this is f1 cos theta minus f2 is equal to MA. If body kept on horizontal is accelerating towards the right under an inclined force, and both of the two forces are there. If body kept on in a horizontal plane is accelerating horizontally towards the right direction, they have two forces now. We have inclined force also. Earlier we had only one force under single inclined force. Earlier it was one single inclined force. This was single inclined force, but now it is both. So this is a two-way. Now this is both ways. So horizontally it is there. This is horizontally it is there, and towards right, and there is an inclined force also. So inclined force and horizontal force. So two forces are there. Now instead of one force, we have two forces. We have two forces now. Two forces here. Okay, let's just go beyond that. We have two forces. To explain it up. Forces F. So one is the inclined force and another is the horizontal force. There are two forces in it. So and this is two forces. So n plus F1 sin theta is equal to mg. Since the body is at rest, when the body is at rest, we can take this. Otherwise, we cannot take this. When the body is at rest, then we have to take this. Otherwise, if it is moving, we cannot take it. This is not applicable in the when the body is moving, and this is not applicable when the body is moving. Not applicable when if the body is moving. If at rest only it is applicable. Not applicable if the body is moving. If the body is moving, अगर body move कर रही है, this is moving. This is not applicable if body is moving. If body is moving in any direction also. So we have to be very cautious about it. Whether it is body is moving, whether it is body is at rest, or so next is body kept on the horizontal plane is accelerating horizontally towards the right. So body kept on horizontal plane is accelerating horizontally towards right under two inclined forces opposite to it. So there are two inclined forces. For the vertical direction, they have taken mg. For the horizontal direction, so this is mg, and here there are two inclined forces there. So here this is making an angle of theta. So here also the same application is there. This is F1, this is F2. So when we go for the x-axis, there are two inclined forces now. One is this one and one is this one. So F1 and F2. So now you have to make again this is a triangle of, and this is the x-axis. Suppose we can name it as f of y, because this is f of y. This is f of y. F of y, and this is f of x, because I have explained this one, and how to find this is whether it is x-axis, f of x. So what will be this is theta. So how to get this, f of x and f of y. So what is the value of the sine theta in it? Sine theta, we can take this triangle we can take up this triangle, and here this is f1, this is fx, this is fy. So sine theta is equal to p by h. P by h, what is perpendicular? P by h. P is this one, this is f of y. So f of y, sine theta, what is the value of the sine theta here? Sine theta will be p by h. Sine theta is equal to p by h. So here p is this one, this is f of y, p by h. P by h is this one, f1. So if you take this here on the opposite side, so fy is equal to f1 sine theta is equal to f1 sine theta, f1 sine theta, f1 sine theta. So this is the value of the fy. Now similarly fx, in this if you take this triangle, fx cos theta will take it. Cos theta is equal to cos theta is equal to p by h. So what is the base here? Base is this one, f of x is equal to f of x divided by f of 2 divided by f of 2. If you take this towards the left direction, f of x is equal to f of x is equal to f sin theta, f2 sin theta, f2 cos theta, sorry, equal to f2 cos theta. So this is the value of fx, f of x and f of y. Force in the direction of the x is what is written. So now body sliding freely on the, when the body is sliding freely, on the inclined plane. Perpendicular to the plane is equal to mj cos theta, whose body is at rest. Body is sliding freely on the inclined plane. So this is the case here. So if we take this triangle, only mg and this triangle only. So this is the base. This will be the base. This is the perpendicular. This is the base now, because where theta is there, the base is formed. This is the base of this triangle. So this is the base of this triangle, and this is mg here. Mg means this is the mg, and we have to find this one. So we can go for like f of x and f of y again. F of x, let's suppose this is f of x, and this is f of y. Suppose this is here. This is the y-axis, this is the x-axis, so this is the f of y. F of y. So here we have to find sine theta now. Suppose cos theta. We have to find the cos theta now. So cos theta is equal to b by h. So this is the base now. This is the base of it, like f of x, and h is mg, perpendicular to the plane. This is the perpendicular to the plane. So this is mg, और ये the base. This is the base of it. इसको मैं क्या माना है, y. f को x of y मानना पड़ेगा, because we have to take this f of y हो जाएगा. Sorry, this is f of y, and here it will be f of x. This will be x-axis, and this is the y-axis. तो f y, this is the base b by h, तो ये हो जाएगा f of y. ये वाला हो जाएगा f of y. This is the like y-axis. तो ये f of y कर देता हूँ इसको. f of y divided by mg. So y-axis is this one, no? ये वाला y-axis है ना, ये वाला. This is the y-axis. तो ये y-axis हो गया, और ये वाला जो है ना, this is n is equal, ये will go with multiply this another side. mg cos theta is equal to f of y. f of y मतलब यही, this is the f of y. So f of y is equal to mg into f of y is equal to mg cos theta. mg cos theta. This is mg cos theta. एफ वाई की साइड डायरेक्शन में कौन सा है? एफ वाई की डायरेक्शन में ये है, ठीक है. एफ वाई की डायरेक्शन इज दिस वन. दिस इज द वाई डायरेक्शन. सो इसमें कौन सा है? दिस इज एन. सो दिस इज इक्वल टू, दिस इज बीन रिप्लेस्ड बाय एन. दिस इज टू बी रिप्लेस्ड बाय एन. ये क्या आ जाएगा? एन, बिकॉज ये वाई एक्सिस है ना. This is the y-axis. This is the y-axis, and now we've moved on from sine theta now. Sine theta is equal to p by h. Sine theta equal to p by h. P is, this is the base. This is the base, this is the perpendicular. So with this direction, this is like x-axis. So f of x x-axis divided by mg. P by h, this is h, hypotenuse. And this is the hypotenuse. We got f of x is equal to mg sine theta. F of x is equal to mg sine theta. Mg sine theta. Please do subscribe my channel because this likes also. Please like my video. I just started doing it. So this is f of x in this direction. It is in this direction. It is the opposite of the acceleration. This is m of a. Force is opposite of the direction of the mass into acceleration. So this is to be replaced by m of a, m into a. M A M A. So this is M A is equal to mg. So m gets cancelled. E is equal to g sine theta. Body pulled parallel to the inclined plane. So case 2. So we can continue tomorrow also at the same time. If you like my channel, then please subscribe my channel. And thanks for watching. Thanks for your support. Thank you. I'm going now. So tomorrow I will continue with this session. And please subscribe my channel and like the video. Thanks for watching and thanks for your support.